making LeetCode way harder than it has to be, and that's why I'm here. This is Fanning 30 for 30. 30 LeetCode questions asked by real interviewers in the last 30 days for the next 30 days.
Still working on the slogan.
We're gonna code up 30 of these solutions for the next 30 days to make sure you can pass that interview and get that top dollar offer. But before we get into the code here, make sure to drop a follow so you're prepared for your next technical interview, and be sure to drop a comment too if you want that GitHub repo. Let's get into the code.
The LeetCode problem we're going to solve today has been asked by Google in the last 30 days, and it's called search and rotated sorted array. There's an integer array nums sorted in ascending order with distinct values. Prior to being passed your functions, nums is possibly left rotated at an unknown index k. Given the array nums, after the possible rotation in an integer target, return the index of the target if it is in nums, or -1 if it is not in nums. You might think the array is unsorted, we can't use binary search. But actually, because there's only one rotation point, we can do some clever tricks here to actually use binary search and solve this in O log n time. What we're first going to do is create 2 pointers at the start and end of the list. Then we're going to start our binary search logic. We're first going to get the midpoint between our 2 pointers, and we can do that with integer division like this. And then at each iteration, we're either going to move our right pointer to our midpoint or our left pointer to our midpoint. The first case to check is if nums mid equals the target. In that case, we're just going to return mid, which is the index of that target value. Now, in a regular binary search, we would just check if nums mid is less than the target, and then if it was, we would check the left side of the array. If it wasn't, we knew it was greater, and we would check the right side of the array. However, because there is rotation in our array, we need to do one more additional check. The first check we're going to do is if nums L is less than or equal to nums mid. What we're checking here is the left half of the array sorted, meaning the rotation occurred somewhere on the right side. In that case, we can just check if the target is in that range with this logic here, because we know it's greater than or equal to the left pointer and less than mid. In that case, we're going to want to move our right pointer to mid -1. If the target's not within that sorted range, we know it's on the other side of our array, so we can move our left pointer to mid +1. If the left half of the array isn't sorted, that means the right half is, and the rotation occurred in the left side of the array. So this else statement is this logic. We're going to do something very similarly, except nums mid will be our starting point. So if nums mid is less than or equal to target is less than nums right, meaning in that sorted half of the array, target exists in between our mid pointer and our right pointer, we can just set L to mid +1. And if that's not the case, we just set our right pointer to mid -1. Now, if the number exists in the sorted array, its index will return in this block. We also need to handle the case in which it doesn't exist, and in that case, we are just going to return -1. And then when we submit our code here, that I actually can't code, now we will see that I still can't code, and I had one logic error here. And finally, we'll see that we passed. I'll see you tomorrow.